Chapter 8, Section 9 is entitled Congruent Figures. What we're talking about here is the process by which proving two shapes are exactly the same. Now that sounds like it's kind of a duh statement like, oh, they're the same, that's it. No, actually, we spend a lot of time in a geometry class talking about why two shapes are the same. Usually that conversation is centered around the idea of triangles, which is exactly where our definitions are going to start here. So let's go ahead and take a look at those definitions. The one definition we have here in 8.9 is the side-side-side rule. The side-side-side rule is a rule stating that if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Now this is kind of a great leap for mathematicians because usually when we're looking at two shapes, two quadrilaterals, two polygons that aren't triangles, usually you have to prove that everything that matches up. That there's, let's say we're talking about two rectangles. You have to prove that the one side is the same as the other side, and the second side is the same as the second side, and the third side is the same as the third side, and the fourth side is the same as the fourth side. And then, not done, you got to go back and show that the first angle is the same as the second angle, and the second angle is the same as the second angle, and the third angle is the same as the third angle, and the fourth angle is the same as the fourth angle. So just to prove that two rectangles are the same, very basic shape, you have to prove 8 different things. That's a lot of work. But these rules here, specifically the side-side-side rule, says that I can prove only 3 of the 6 things about a triangle are the same. 3 sides, 3 angles is how I come up with 6. You can only prove 3 of the 6 things here and end up proving that 2 triangles are exactly the same. It's an interesting thing, something you'll spend a lot more time talking about in the formal geometry class, and you'll also learn that there's other ways to prove that 2 triangles are the same. There's a rule called angle, side, angle, which you can use to prove that 2 triangles are exactly the same, and there's also a rule called side, angle, side that you can use to prove that 2 triangles are the same. Okay, so let's take all our knowledge here of congruent figures and see what we can do here. We'll start with number 1. We're asked to identify any congruent figures here. Well, just looking at the sides, we're in trouble here. Because as you can see, the interior markings of this stop sign here are different than the ones on the outside. Obviously, the ones on the inside have to be shorter because that's why that stop sign fits inside the other stop sign. Well, since the sides here of our stop signs, the sides of our octagons can't be the same, that automatically means that we don't have congruent figures. Once you're able to prove that even one thing doesn't match up, you're not able to prove congruent figures anymore. And that's all we had to do here, number 1. We found, looking at that bottom side there, that those can't possibly be the same lengths, so these shapes are not congruent. Now, in number 2, we're looking at the triangles we have here. And when we're talking about these triangles here, what we have to prove is that side-side-side rule that we saw in the definitions. So we want to show that one side in the triangle on the left is the same as another side in the triangle on the right. Pick a different side on the triangle on the left is the same as another side of the triangle on the right. And then the remaining side in the triangle on the left is the same as the remaining side in the triangle on the right. And if we can prove that, totally disregarding the angles then, we can say that the 2 triangles are congruent. Well, let's take a look. We've got side AB here that measures 4. So we're looking for something else marked 4 over here. Well, that works out okay, because as you can see, they're showing you here that PQ measures 4. So far, so good. Alright, and then we've got side BC here, which is marked 4. So we need another side that's marked 4. I can't come back to the side I've already used. I got to go somewhere else. So I went to this one here that's marked 4. That's good. That works. So far, side set 1, side set 2, it's all good. But then when we get to what's left here, I got a 6 and a 5. Well, that's a problem. If it was 6 and a 6 or a 5 and a 5, life would be good. Unfortunately, it's not a 6 and a 6. It's not a 5 and a 5. It's 2 totally different side sets altogether here. So since those 2 guys are not the same, that means that the triangles are not congruent. It doesn't meet our theorem here of side, side, side. So even though we've got 2 sets that do match up, because the third sides are not the same, these 2 shapes end up not being congruent.